Look, the shift from basic prompt response chat to these so-called agentic architectures has sparked a massive wave of commercial enthusiasm, hype that is honestly completely detached from reality. Welcome to this explainer. Today, we're stepping away from the buzzwords, we're picking up a marker, and we're heading straight to the whiteboard for a no-nonsense, highly analytical audit. We are going to demystify autonomous agent loops. Let's get into the actual architectural facts. I'm going to start us off with a very blunt reality check. Stop buying loop engineering courses. Seriously, right now, the internet is absolutely flooded with gurus repackaging fundamental software engineering concepts just to sell you on this empty hype about unattended software factories. You know the pitch, right? They promise you can just define a loop, go to sleep, and magically wake up to a fully built software empire. Well, it sounds way too good to be true because it is. We really need to expose how these narratives completely ignore the harsh functional realities of how software actually executes. So let's just state this definitively right up front. For about 90% of your daily work, deterministic single-pass prompting is absolutely not dead. Despite all the relentless marketing claims pushing autonomous multi-agent systems, standard structured prompting and deterministic control flows remain the production standard for the vast majority of real-world enterprise workflows. I mean, think about it. If you're building systems for strict compliance or heavy data processing, you want a highly accurate, precise workflow with zero tolerance for variance. That is exactly what standard prompting gives you. There is a massive gap between commercial marketing hype and functional software reality. The hype will tell you that your machine is achieving true cognitive autonomy through some magic custom outer loop configurations, saving you tokens and literally replacing human developers. But the reality? System agency is strictly bound by token context limits and hard execution boundaries. Instead of saving tokens, these recursive validation cycles actually cause your token usage to scale exponentially. And the developer's workload? It doesn't just vanish. No, it simply shifts. You end up spending all your time writing complex validation assertions, setting up sandbox tooling, and drafting incredibly strict specifications just to prevent the model from experiencing cognitive drift. Okay, moving on to section 1, the architectural truth. Linear prompting versus true AI loops. Picture a single straight line drawn right across a whiteboard. That line represents deterministic prompting. For your everyday consumer AI use, think of your standard ChatGPT or Gemini interfaces, loop engineering is functionally non-existent. These apps run on stateless, single-pass, request and response pipelines. They are literally just a linear input-output system. Because they lack execution sandboxes, they don't have native tool integration protocols, and there's no state persistence middleware, they simply cannot run autonomous loops. Any attempt to simulate a loop in a basic chat box relies entirely on you, the human, sitting there and manually providing iterative feedback. Now, imagine sketching a circular flowchart next to that straight line. This cycle is the structural foundation of a true agentic cycle, modeled on heavy-duty architectures like the Microsoft Agent Framework or CrewAI. This kind of system doesn't just respond, it acts. The loop operates across 5 very distinct stages. First, perceive. The system captures the incoming data. Second, reason. The model processes those inputs to figure out the next action. Third, plan. The agent breaks the main goal down into subtasks. Fourth, act. The model emits a structured tool call to execute external actions. And finally, observe. The environment actually runs the tool and feeds the raw output right back into the context window, kicking off the next iteration. So the absolute crucial takeaway here is that running a true loop is not just about writing a better prompt. It requires mandatory, heavy infrastructure. To make that 5-stage cycle actually function in a production environment, you need state persistence middleware just to track the session. You need secure execution sandboxes so the model can safely run code. You have to have tool integration protocols like Anthropic's Model Context Protocol, for example. And you need those heavy orchestration frameworks we just mentioned, like CrewAI. All of this infrastructure is exactly why those consumer chat apps functionally cannot run autonomous loops on their own. They just don't have the plumbing for it. Which brings us to section 2, when to use what? Let's lay down some hard engineering rules for AI architecture. Let's map out this spectrum of complexity. At the base level, you have a direct model call. This is for human-in-the-loop, single-step tasks. Look, if prompt engineering solves your problem, you do not need an agent. Full stop. Moving up a level, you have a single agent with tools. This loops through actions, but strictly within one domain, which is perfect for dynamic logic, like doing order lookups. Finally, at the very top, you have multi-agent orchestration. This involves highly specialized agents coordinating with each other. Now, this adds massive coordination overhead, network latency, and serious cost. You should only be deploying this for autonomous background infrastructure where cross-domain problems absolutely demand parallel specialization. And look, if you ignore these rules, you are going to run headfirst into the severe risks of unattended loops. Executing continuous loops without strict oversight introduces extreme resource overhead. First up is exponential token scaling. Because every sub-agent maintains its own chat history and tool registry context, your total token consumption is going to grow incredibly fast. Second is loss of architectural comprehension. When you have multiple sub-agents writing code in parallel branches all at once, human developers completely lose their mental model of the code base. You won't even know how your own app works anymore. And third, my personal favorite, software psychosis. Unregulated token generation and recursive rewriting cycles often just produce sprawling, highly nested, unmaintainable code. It's essentially a machine hallucinating an entire digital labyrinth, just trying to satisfy some arbitrary termination condition. All right, let's look at Section 3, the Real Agent Blueprint. We'll use an e-commerce catalog management system as our real-world example. Managing product catalogs for large-scale e-commerce stores means processing absolutely massive data volumes securely. If we were to sketch out a block diagram for this pipeline architecture, it starts with a shared environment state. In software engineering, we call this the blackboard pattern. See, instead of forwarding bloated conversation logs back and forth between agents, they communicate by reading and writing to a shared database. This STIG-mergy-based pattern can literally reduce your total API token consumption by up to 80%. Next in the diagram, a router agent utilizes model context protocol servers to securely pull inventory files and verify product listings. And the whole shebang is backed by persistent storage, using something like SQLite flow persistence, so you preserve complete immutable audit logs of every single state change.
But here is the absolute most critical engineering safeguard you must implement: risk-tiered execution. The agent that writes the work must not be the agent that blindly approves it. For low-risk execution, things like drafting product descriptions or SEO alt text, sure, the system can execute autonomously using Pydantic models to ensure the output data cleanly matches your database schemas. But for high-risk execution, we're talking modifying active prices or processing actual customer refunds. For that, the workflow strictly pauses. It generates a transaction-safe state checkpoint, submits an authorization request, and it only resumes after explicit human validation. Remember this rule: as long as you know something the agent doesn't, you need to stay in the loop.
To sum it all up, a prompt says what to do. A loop says when to stop. Stop just prompting your agent turn by turn, and instead design the underlying system that prompts it for you. But you have to do it with a strict, sober understanding of the architectural facts. Your value as a developer hasn't disappeared, it's just shifted. It's shifted to defining the system intent and maintaining strict accountability for what actually ships to production. Master the architecture and ignore the hype. Are you building robust systems with clear stopping conditions, or are you just letting a language model blindly judge its own work? Definitely something to think about as you design your next workflow.